Hello. So, uh, thank you for being here. All right, students. So today we will talk about the AIET 2, that's 12th class, first of all. Okay. So let's discuss with its solutions and how was the paper quality and how it has been, how you were supposed to attempt it. All right. So I'll start with the very first question. The question is, fx is fx is 2k plus 1x minus 3 minus k e to the power minus x plus 2 e to the power x is monotonically increasing always. Got it? Given monotonically increasing for every x belongs to R. So how do we do it? What you need to do? First of all, find the derivative. F dash x is what? It is 2k plus 1 plus k e to the power minus x plus 2 e to the power x. Am I clear? Got it? Let's multiply this equation. And what do you want? It's monotonically increasing, means this should be greater than 0 or at times equals to 0. Got it? So multiply this equation by e to the power x. You get 2 e to the power 2x plus 2k plus 1 into e to the power x plus k. It should be more than or equals to 0. Now that is 2 e to the power x. I'm left with e to the power x plus k plus 1 into e to the power x plus k more than equals to 0. So 2 times e to the power x plus 1 into e to the power x plus k more than or equals to 0. Now we are already aware that this is always greater than 0 because e to the power x is more than 0. So what do you want? That this e to the power x plus k is more than or equals to 0 for every to R. And if you want this thing to happen, that means k should be greater than or equals to 0 for every x belongs to R. Got it? So least value of x is what? 0. I hope I have made my point very clear. Easy question it was. Now, how many real solutions does this equation have? See, this is an odd degree polynomial. So necessarily at least one solution is there. Now, if I assume it as a function, got it? Let us assume this is fx equals to x to the power 7 plus 14 times x to the power 5 plus 16x cube plus 30x minus 560. If you differentiate it once, if I differentiate it once, f dash x will be what? 7 times x to the power 6, 70 times x to the power 4, 48 times x square and plus 30. Do you see? Everything is positive and is being added. Everything is positive and is being added. That means f dash x is greater than 0 for every x belongs to R. So if it is always greater than 0 means function is always increasing. And being an always increasing function, it will intersect the x-axis at only one point. So how many real solutions? That means only one real solution. All right. Now see this question, that's an easy treat. Let f from R to R be a function defined as fx is this. See, for the function to be continuous, they are talking about the continuity, f of 1 minus should be equals to f of 1 plus should be equals to f of 1. Now, before 1 value is 5, after 1 value is a plus b. So an equation in a and b is a plus b equals to 5. Got it? Now, f of 3 minus should be equals to f of 3 plus should be equal to f of 3. That means f of 3 minus is what? 3b plus a is f of 3 plus will be b plus 50. So from there I get another equation 2b plus a equals to 50. Got it? Now if you realize a equals to minus 5 and b equals to 10 satisfies these two equations. But there is another 0.5. f of 5 minus should be equals to f of 5 plus. F of 5 minus will be b plus 25 should be equals to f of 5 plus. 5 plus is going 30. So with this, I'm getting b as 5. So now there is a contradiction because they are saying b is 10. If they are saying b is 10, so this is the contradiction. That means no solution. So not continuous for any value of a and b. All right. Now, this question number 64. Okay, I'll do it here. See, first of all, let's talk about nth term. Nth term will be tan inverse of 1 upon x square. Now see, coefficient of x is 1, 3, 5 and going like. So it is 2n plus 1 into x square plus 2n plus 1 into x plus 2n plus 1. Now it can be written as tan inverse 1 upon 1 plus x square plus 2n plus 1x plus 2n. If you factorize this particular portion, if I factorize this particular portion, this will be 1 plus x plus 2n and x plus n and x plus n plus 1. Just a moment. And into a minus b upon, I want 1 plus ab. So 1 plus ab means 1, 3, 5. Mm, 1 I separated, 2n. So factors of 2n, which when added gives 2n plus 1. So that will be 2n and 1. Four and 1. Up to 2nth term they are asking. I have did it up to nth term. So up to nth term, it will be 1, 3, 5. 1, 3, 5. Nth term goes 2n minus 1. I made a little mistake here. 2n minus 1. So with this, it will become 1 plus x square plus 2n minus 1 into x plus 2n minus 2. Got it? So now it will be 2n minus 2. Factors of 2n minus 2. N and n minus 1. There is some problem. Okay, if I don't do it this way, if I do it like tan inverse of 1 upon 1 plus x into x plus 1 plus tan inverse of 1 upon 1 plus x square plus 3x plus 2 plus tan inverse of 1 upon 1 plus x square plus 5x plus 6 plus 6. It should be like this. There is some problem with this. Got it? It should be, let me correct the problem first. I think this nth term should be something like tan inverse of x plus n minus tan inverse of x plus n minus 1. Got it? So it is tan inverse of x plus n minus x plus n minus 1 upon 1 plus x plus n into x plus n minus 1. So it is tan inverse of 1 upon 1 plus x square plus 2n minus 1 into x plus n into n minus 1. So that means it should be total n square. So tan inverse of 1 upon 1 upon x square plus 2n minus 1 into x plus n square. So in the third term, in the second term, it should be, say, if n is 1, it is x square plus x plus 1. In the second term, it is x square plus 3x. It should be n into n minus 1. So n square minus n plus 1. N square minus n plus 1. So in the second term, T2, it should be 4 and 1, 5 minus 2, 3. In the third term, it should be 9 and 1, 10 minus 3. It should be 7. Then only it is correct. All right. So with this, basically the nth term should be tan inverse of x plus n minus tan inverse of x plus n minus 1. I got confused with the third term. That is why we were not getting it correct. Now that's it. So sum of the series for 2n terms will be tan inverse of x plus 2n minus tan inverse x. This was the nth term. So y2n 0 will be tan inverse of 2n. Got it? Tan inverse of 2n. Now, there's another question. Let fx be a function which is differentiable any number of times and f of 2x square minus 1. F of 2x square minus 1 is 2x cube fx. Got it? For every x belongs to R, then f of 2010. 2010 means nth order derivative occurring 2010 times. Let's do one thing. First of all, let us replace x by minus x. So you get 2x square minus 1 is minus of 2x cube into f of minus x. Am I correct? So if it is equation 1, it is equation 2. What do I get? If I divide both the equations, I get 1 equals to fx upon f of minus x with the negative sign. That means fx plus f of minus x is getting 0. That means fx is an odd function. Got it? If it is an odd function, so even order derivative. See, odd function, first derivative will be even. Second derivative will be again odd. Third derivative will be even. Fourth derivative will be odd. So even number of derivative, if you do, you ultimately get an odd function. So f of 2010 at x equal to 0. Even number of times you are differentiating it. So you are getting an odd function. So it will be passing through the origin. All right. Yes. Got it. Now, to 66, if you see 1 plus under root of 1 plus 8 and alpha is 1 plus under root of 1 minus a, then sine 4 alpha. See, you do one substitution. You replace a by sine 4 theta. You will get it whatever you want. All right. Now, 67 and 68 are quite easy. You can do them on your own. Come to question number 69. 69 is, it is 4 times x square minus 6x plus 16 times y square minus 2y equals to 1. To make a perfect square, I add 9, subtract 9. I add 1, subtract 1. So with this, I got 4 times x minus 3 whole square plus 16 times y minus 1 whole square is 9 4 the 36, 1 plus 36 plus 16, 53. So what do you get? X minus 3 whole square upon 53 by 4 plus y minus 1 whole square upon 53 by 16 is getting 1. So this is an ellipse. Ellipse eccentricity will be under root of 1 minus b square by a square. That is under root of 3 by 2. Got it? Now, next question is this. There are two functions. One is y equals to x upon n. Other is y equals to sine pi x mod. So what do you have to do? We will draw both the functions on same coordinate axis. And then we will see how many points they will intersect. N belongs to has maximum point of non-differentiability for 0 to 4. Then n cannot be. Now see, graph of sine pi x will be like this. Mod sine pi x. It is 0, 1, 2, 3, and this point is 4. Got it? Now there is a line y equals to x upon n. For maximum points of non-differentiability, what do I want? At 4, this should go above the axis like this. The graph of this line should be something like this. Am I clear? So at 4, the value of this should be more than 1. Got it? That means n should be somehow greater than or equals to 4 for maximum points of non-differentiability. So in that case, value cannot be 2. That is your correct answer. Got it? Well, simple question. A is Aij 3 by 3, B is Bij 3 by 3, where Bij is this. Number of such matrices A whose elements are selected from the set such that A equals to B. Now see, if A equals to B, that means Aij is equals to Bij. And Bij is given to you as Aij plus Aji upon 2. With this relation, I get Aij is equals to Aji. If it is so, that means A is a symmetric matrix. I hope I am clear up to this point. And since A is a symmetric matrix, so A11, A12, A13, A21, A22, A23, A31, A32, A33. Now see, A12 can be selected in 4 ways. A13 can be selected in 4 ways. A23 can be selected in 4 ways. Now, if this is selected, this is automatically selected. You don't have to make any selection for this. Similarly, this is selected, this is automatically selected, and this is selected, this is automatically selected. Now, each diagonal element can be occupied again in 4 ways. So, into 4 cubes. So, your answer is 4 raised to the power 6. Got it? So, that is 2 raised to the power 12. I hope I am very much clear. Now, this question number 72. Now, see, 72 is again a good question. F from R to R be a function defined by this. Number of integers in the solution set of x satisfying this inequality. See, if you see fx very clearly, here f dash x is what? F dash x is minus 3x square minus 6x minus 6. Got it? That is minus 3 times x square plus 2x plus 2. Now its d is negative. So this fx is always less than 0. Sorry, f dash x is less than 0 for every x belongs to R. If it is so, that means f is a decreasing function. Got it? If f is a decreasing function, from this inequality, if I remove this f, I will have to change the sign of inequality. And then again, I will remove this f. So I will again change the sign of inequality. So 2 times sign of inequality changed. So that means it remains same. So x cube plus fx is greater than or equals to minus fx minus x cube. So it is fx plus x cube more than or equals to 0. Am I correct? Now fx you already have minus x cube minus 3x square minus 6x plus 1. You replace it there. So fx plus x cube means minus 3x square minus 6x plus 1. It should be greater than or equal to 0. Now you can simplify this and get the integral values of x satisfying this inequality. All right. Now see this question, 74. 73 is a formula based question. You can do it. A is cos 4 pi by 3 plus iota sine 4 pi by 3. A is cos 4 pi by 3 plus iota sine 4 pi by 3. Now if I simplify it, 1 plus a by 2, that is 1 plus cos 4 pi by 3 plus iota sine 4 pi by 3 whole divided by 2. This 1 plus cos theta can be written as 2 cos square pi by 3 plus iota 2 sine 2 pi by 3 cos 2 pi by 3 upon 2. These 2 cancel. So it is like cos 2 pi by 3 into e to the power iota 2 pi by 3. So 1 plus a by 2 raised to the power 3n. Now cos 2 pi by 3 is minus cos pi by 3. That is minus 1 by 2 raised to the power 3n. And simultaneously it will be iota 2n pi. That is cos 2n pi plus iota sine 2n pi, that is minus 1 plus 1. So answer is minus 1 raised to the power n upon 3 to the power 2n. Because 3 is odd, only n will decide the sign is positive or negative. Well, let's go with this question. For a positive integer m, if limit x approaches to infinite, x cube ln of 1 plus 1 by x plus x by 2 minus x square. This is the question. All right. First of all, I replace x by 1 by t. So it will be limit t approaches to 0, ln of 1 plus t upon t cube plus 1 upon 2t and minus 1 by t square. Got it? If you take LCM, it will be limit t approaches to 0. LCM will be 2t cube. So 2 times ln 1 plus t minus t plus t square minus 2t. Now see, even L hospital is a better way to approach. Limit t approaches to 0. Derivative of the numerator is 2 upon 1 plus t plus 2t minus 2 upon 6t square. Now if I take LCM, limit t approaches to 0, we take 2 common. LCM will be 1 plus t into 6t square. It is 1 plus t square minus 1 minus t. Got it? So it is limit t approaches to 0. 1 and t cancel. It is 2t square upon 1 plus t into 6t square. T square cancel. Answer is came 1 by 3. That is the correct answer. All right. Now the question is, let px is, this is a good question. X raised to power 6 minus x raised to power 5 minus x cube minus x square minus x, and qx is this. If alpha, beta, gamma, delta are the roots of this equation. See, if you divide px by qx, you get quotient as x square plus 1, and you get remainder as x square minus x plus 1. That means px can be written as x square plus 1 into qx plus x square minus x plus 1. Am I correct? So now if you do p alpha plus p beta plus p gamma plus p delta. Now see, this q alpha, q beta, q gamma, q delta will become 0 because alpha, beta, gamma, delta are the roots of qx. So what do you get? You get sigma alpha square minus sigma alpha plus 4. Got it? The sigma alpha square is sigma alpha whole square minus 2 sigma alpha beta minus sigma alpha plus 4. Now, sum of all the roots from the qx will be 1. So it is 1 minus 2 times. Sigma alpha beta means sum of roots taken 2 at a time. It will be minus 1 minus again sum of all the roots 1 and plus 4. So it became 1 1 cancel, 4 and 2 6. Am I clear? Now very good. This is done. Now let's jump to this 77 question. A is a square matrix of order 3. Determinant of A is 5. Value of this. See, they are asking for 2 times A dash determinant. If A is a 3 by 3 matrix, I take 2 common from each row, it will become 8 times determinant of A dash. That is 8 times determinant of A, and determinant of A is given to you as 5. So 8 5s are 40 is your answer. Got it? Now, question number 78. Now see, the 78 is this. Fx is given as sine inverse of 2x minus x square, then under root of 2 minus 1 upon mod x, and then 1 upon greatest integer of x square. See, this is a simple question. What you have to do, 2x minus x square, it should lie in minus 1 to 1. One condition. Second is 2 minus 1 upon mod x should be greater than equal to 0. Second condition. And the third condition is greatest integer of x square should not be 0. I will start discussing from this condition. See, x square should not lie in 0 to 1. Am I correct? That means x should not lie in minus 1 to 1. Now x should not lie in minus 1 to 1. With this, d rejected. 1 minus root 2 to 1 includes 0 also. This is rejected. 1 minus something to 1 plus, this is also rejected. This is the only correct answer. We should always keep our mind open. Got it? Now, see the question number 79. If the coefficient of x to the power 7 in this is equals to the coefficient of x to the power minus 7 in this. That is simple enough. Coefficient of x to the power 7 in this, you can easily calculate. It will be 11c5 a to the power 6 upon b to the power 5. And coefficient of x to the power minus 7 here will be 11c6 a to the power 5 upon b to the power 6. Got it? You just equate it. You will get ab equals to 1. Now this is easy. Now, question number 81. Which term is the least positive value if the first two terms of AP are these? See, it's a decreasing AP. What you will have to do, you just find the nth term and make it greater than 0. So what is the value of n you are getting? That will be your answer. Got it? Now, number of terms free from the radical sign. You have tried enough of this. Am I correct? Now, all are quite a doable question. I'll do question number 84. Got it? See, question number 84 is sine theta upon cos 3 theta, sine 3 theta upon cos 9 theta, sine 9 theta upon cos 27 theta. See, this sine theta upon cos 3 theta, I can write it sine theta multiply by another cos theta, it will become cos theta cos 3 theta. Got it? Multiply and divide by 2. Numerator became sine 2 theta upon 2 cos theta cos 3 theta. It can be written as sine 3 theta minus theta upon 2 cos theta cos 3 theta. Now, it is, if you expand it, you get half of tan 3 theta minus tan theta. Am I correct? Similarly, if I go with sine 3 theta upon cos 9 theta, that will be half of tan 9 theta minus tan 3 theta. And similarly, sine 9 theta upon cos 27 theta will be half of tan 27 theta minus tan 9 theta. Alright, now you add all of them and you will get what you require. Now, rest are good questions. You just attempt them, and multiple integer type always have a choice. So there are definitely 6 to 7 very easy questions always. All right, that would be all from me today. And I hope you enjoyed the solution. Thank you so much.